of the review goes back to the beginning of the module. So it says fill in the chart. We're doing words, expressions, and then the value of the expression means the answer. 50 times the sum of 45 and 52. Now, if you don't remember this now, it's going to come back to you. Yosin, what math word should I underline in this first one?
Times.
Times and sum. Now, when I ask someone a question, I want them to answer. Okay, so pay attention to the words I say. So 50 times the sum of 45 and 52. So what two operations am I going to do? Multiply and add. Okay. So let's put it in there. 50 times. Then do you remember your parentheses?
Yes.
And that's where I put sum. 45 and 52. Okay, 45 plus 52. Anybody already do that in their head? Don't shout it out. Just raise your hand when you've got it. Christian?
97.
97. So how would you solve 50 times 97? What would you do, Lexi? Standard algorithm. I'm going to go ahead and do 97 times 5, though. And then I'll add a 0 to the end. Don't you think?
Yeah.
So 35. Is that what you got?
Yep.
So the answer to that problem is 4,850. Okay? Okay, we're going to keep doing the same thing. The next one says divide the difference between 1,500 and 800 by 5. Lupita, what math word should I underline there?
Divide
Divide, and there's one more.
and by. No, different.
Difference. By is pretty important, you're right, because you're going to divide by something. What do you think you're going to divide by, Genesis? 5. And when you divide by something, it needs to be at the end of your expression. Because otherwise, you can't do it, really. And I'll explain why in a minute. So what does difference mean, Mario?
The answer to division.
Not division, difference. Subtraction, okay? So what do you think goes in my parentheses?
Minus.
Yeah, subtraction problem. And I'm not going to change the order of those numbers since it's subtraction. Okay, so what this means is, Tobias, what's the answer to 1,500 minus 800? Do 15 minus 8.
7.
And then add 700. Okay. So what this means is, when I say you have to divide at the end of the expression, because I wouldn't do 5 divided by first, would I?
No.
No. I have to do 700 divided by 5. Okay, and the best way to do it, boys and girls, what do you think, since I wrote it down already? Long division. Okay. So how many groups of 7 can I make? How many groups of 5 can I make out of 7?
1.
How many groups of 5 can I make out of 20?
4.
Are you writing this down? And what do I do, Anna, if I break down the number and I can't divide and I end up with a 0?
0.
What do I have to do at the top when I can't divide?
Remainder
Put a 0. Because we wouldn't put a remainder of 0, would we? No. Okay, so my answer here, what is it, boys and girls? 140. Okay, C is pretty hard, but you can do it. The sum of 4 15s and 16 15s. Morgan, what math words should I underline? Sum. Uh-oh. That's not enough math words, is it?
Yeah.
So they left something out. Okay, so I'm going to say this a different way. All right. Oh, do you remember, Yossi? The sum of 4 groups of 15
The
and 16 groups of 15.
of is for
You're right. What is it? Multiplication. Okay. And do you remember sometimes we even stuck that in there to be groups of? So this one is going to start out like that. And then I have 4 groups of 15, Miley. How do I write that?
14 times 5.
4 groups of 15 and 16 groups of 15. Now right away, I can tell you how I would have solved this when I was your age. I would have done 2 multiplication problems and added it together. But we don't want to do the standard algorithm, do we, boys and girls?
No.
Especially me. My goal is to figure out how to do it without. So, what could I do? Instead of multiplying first, what if I added first? Okay, think about that for a minute. What would you add together if you were going to add it first? Would you add your 15s or would you add your 4 and your 16?
15. 4 and 16.
I would add my 4 and 16 because the 15s are the same. So I'm going to multiply by 15 on both of them. So I could do 4 plus 16 first. And what does that equal?
20.
20, and then 20 times 15. 2 times 15, boys and girls, what is it?
30.
And add a 0 to the end. So what do you think?
Yes.
When you see a problem like this, it's either going to have plus or minus in the middle. You might want to try adding or subtracting first before you multiply, okay? Oh, by the way, this word 15s, since it's on there twice, I know that we're multiplying everything times 15. Okay, D. It says 15 times the sum of 13 and 7. Jose, what should I underline?
Times.
And good. And was A just like this?
Yeah.
Okay, go ahead and do it yourself then. See if you can figure out what to write. And then check it with mine when you get back up here. Or when you look back up here. Is that what you wrote? Good.
Yep.
Now how do you solve it?
You
What do you do first, add or multiply?
add.
Okay, so I'm thinking that I already know the answer to this.
Yes.
What's the answer?
300.
15 times 20 is 300. Okay, E, it's not there.
You have to figure. So we have.
So I got, yeah, we're gonna have to figure it out. Can we look at our operation signs?
Yeah.
Okay, when I multiply, what word am I going to use?
Times.
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 And when I add,
Sum.
okay, so do you want to try it for me, Christian? Go ahead, say it.
10 times the sum of 375 plus
And,
and 84.
okay, Anna, I'm gonna have you do the next one. 10 times the sum of 375 and 84. Now I'm already thinking ahead to the times 10. When I multiply times 10, what do I add to the end?
0.
Okay, so all I have to do is add those together and then put a 0 on the end. Did anybody already add them together? Go ahead and add them now. I'm going to use standard algorithm so I don't make a mistake on this one. Go ahead and add. Is that what you got?
Yeah.
So the answer, Jose, is what?
4,590.
Good. You're doing a really nice job today, boys and girls. Okay, Anna, What two words are you going to use here in F?
Times and sum.
Okay, now, I don't care what order you do it in. You can put sum first, like it is in the problem, Daniel. Or you can put times first, like we did in the others. Okay,
14 times the sum of 530 and 470.
good. Daniel, did you add those two together already?
Yeah.
I knew it. What do they equal?
14,000.
1,000. So if I add these two together, it's 1,000. Oh, thank goodness. I can do that in my head. What is it, Daniel?
14,000.
Okay. All right, think you can handle that, number one?
Yeah.
Okay, it's worth 12 points tomorrow on your test.
That's a lot.
Yes. Okay, let's go down and take a look at number 2. Now I want you to cross something off on here. Does anyone see what I might want you to cross off?
B. B.
What's my rule for getting these right? Calculate them. So why would I want you to do it without calculating? Now I'm going to give you some tricks today that are going to help. Okay? I think the best thing to do is just do the math. Don't you? Calculate it. What's 5 times 6?
36.
And so 25 times 30. Don't say this out loud, but you know what 3 quarters is, don't you?
Yep.
Okay. Genesis, how much is 3 quarters? You know, like if you go to the concession stand and
75.
75 cents, right? And then add the 0 to the end. So which one of these is larger, Gabby? Left or right?
Right.
Correct.
It's only 50 more.
Okay, here's the strategy to use on B and C. It's very important. Don't work ahead. I'm going to change this to, because I noticed that I've got unit form over here. So I'm going to change the first one to unit form. And I notice that I've got the same word here and the same factor here. So I'm going to make this 76 what? 11s. Then I want you to look at it and don't shout out the answer. Just look at it. 76 11s and 80 11s minus 5 11s. What do you think, Lupita?
Equal?
No. You gonna change it? What?
76 11 is bigger.
Okay, how many 11s is over here?
80.
80 minus 5, what is that?
75.
See why unit form helps a lot right there? Okay, yeah, I know you were. Okay, so if I change this to unit form, I have to start by looking at the number they wrote, 26. So that has to be the word. So I'm not going to do 26 48s. What am I going to do?
48.
48 26s. Okay, now just look at it. Don't shout it out. So 48 26s and 24 26s doubled. Tobias, what do you think?
They're equal.
Why do you say they're equal?
Because 24 plus 24 equals 48, and then you have the 26's equals 48 26's.
Is he right?
Yes.
I was thinking 24 times 2, but it's actually easier to double it with an addition problem. So he's right, it's equal. Good job. Okay, think you can handle that tomorrow?
Yes.
You don't have to explain because I like it when you calculate.
How much points is that one?
That one's only worth 3.
Okay.
Don't worry, it's better on the back. Okay. Actually, number 3 is the hardest one for students in my past classes to get correct.
What?
Because of the way it's worded on here. So this is what it says, okay? It says 35 times 60 equals blank. 3.5 times 60 equals blank tenths times 60. It's unit form, so I'm going to try and help you, okay? So if I were to write A like they did B, here's how I would write it. 35 ones times 60 equals, and then I would write the answer, okay? So instead of ones, what did they use? So what number goes here? How many tenths? 35 tenths. So all they did was change it to unit form. They did 3 5 tenths is the same thing as 35 tenths times 60. Okay, that's all they did. Now someone do 35 times 60 for me. And I'm going to do 35 times 6. And then add a 0 to the end. So what did I get for my answer? Okay, so if I do the same thing over here, I'll get 2,100 what? Tenths. Here's what they left off. Equals something. Rewrite it in standard form. Emily, 2,100 tenths is equal to what in standard form? 210, right? Because you're going to underline one digit and place the decimal. Okay? Now, explain that to me. What do we do? Were the digits all the same?
Yes.
Okay, let's put that. The digits were all the same.
When do we have this test?
Tomorrow. So if you go to the basketball game tonight, you're going to have to study during the game. I'm just kidding.
I'll study it when I get home.
Okay, thank you. The digits were all the same. What changed? Tobias, what changed?
Where the decimal is placed.
That's right. So what changed? The place value. The place value.
The place value.
So the place value in, I'm going to say B for problem B, don't you think?
Yeah.
Is in the what place? Tenths place. That's the only difference. So what's the answer to a multiplication problem?
Oh,
No.
times.
The
Product.
answer.
Product.
Product. So the product should be okay, let's see if that makes sense. The digits were all the same. The place value in B is in the tenths place, so the product should be in the tenths place. I could add the word also at the end, right? Okay.
Wait, are we gonna have to write this on the test?
Well, if you can memorize that, then that'll give you the answer for the test. Yes, because all I did was change the digits.
I can write it on my hand maybe.
Now, here's what I want you to know. On your test, this number right here, 2,100, it's not a 4-digit number. It's only a 3-digit number. Okay? So that's going to be different, but it still shows tenths place over here. Here's what kids can't figure out. Between that bracket and this bracket, All it is unit form. If I highlight that, and let me highlight it with a really light color. If I highlight this right here, I'm gonna have to get it bigger, aren't I? All it is unit form. 35 tenths times 60 equals 2,100 tenths. Okay, go to page 3. We'll come back to these if we have time. Remember what I said about your stamina? This is going to help because we're going to not save this till the end today.
How much points is that?
That one was worth, number 3 was worth 5 points. The total on the back page is 14 points.
Wow.
Or 16. I can't remember. I'll have to look. Okay, let me read it. You remember how the last problem usually it all goes together?
Yeah.
Okay, all right. So Marcy makes hair bows to sell at the craft fair. Each bow requires 2.5 yards of ribbon. That's a lot of ribbon.
Yeah.
Okay, that's like 2 yardsticks, and then another half.
Like
Okay.
a ruler?
No, like
big ones.
now the meter is what I have here, but remember the yardstick was 3 inches smaller than this, right? So that's a lot of ribbon.
Wow.
I guess it's going to be a huge bow. Okay,
Like an elephant.
okay. So let's talk about, now you're going to have to remember how many yards it is, so I would go ahead and highlight that. I hope it's not. I hope it's 2.5. Okay. All right. At the fabric store, ribbon is sold by the foot.
Underline foot.
Mm-hmm.
Or box.
If Marcy wants to make 74 bows,
70.
how many feet of ribbon must she buy? Show all your work. So we have 2 things we have to do here, don't we, Yosin?
Yeah.
What's the first thing we need to do?
You have to multiply.
Not yet. Let's wait to multiply. Let's figure out how much it is for 1 bow. Right?
Yeah.
I know how many yards it is, but that's not going to help me if I have to go by feet of ribbon. So what do I have to figure out first?
Which one bow?
I need to figure out 1 bow, but I've got to change yards to what?
Feet.
Feet. Says it right up there. So my formula for doing that is the 3 equal signs, right?
Yeah.
Okay. So I'm going to do 2.5 copies of what?
1 yard.
1 yard. You know how to do this. Daniel, do you remember how many feet are in a yard? I laid out the rulers on the floor.
3.
Very good. So I'm going to change that to 3 feet right there. Now to solve the problem, all I have to do is 2.5 times 3. But if I think 25 tenths times 3, what do I get? 3/4.
75.
75 tenths. What is it? 7.5 feet. So now we know we need 7.5 feet to make 1 bow.
That's a lot. That's a lot.
Now on your test, it's less than that.
Oh.
Okay, but in order to give you a chance to practice, so that's 1 bow. Now, Jose, how am I going to figure out 74 bows? I'm going to take my total feet, which is what? 7.5 times what number to figure out 74 bows? Yep. So I could do this one of 2 ways. I could do 75 tenths, or I could just leave the decimal in there. Because we know how to place it at the end, don't we?
Yeah.
Okay, 2 partial products in this problem. Oops.
both.
Okay, and the mistake children make most of the time on this problem, they forget to place the decimal in their answer.
I did put it, but when I saw you didn't put it, I erased it.
Okay, so the answer is how many feet, Miley? She will need to buy how many feet of ribbon? What's my answer right here?
555.
Feet. She will need to buy 555 feet of ribbon. Now, if your multiplication was incorrect, take a minute and figure out where you made your mistake.
I got it right.
Okay? And if it was right, just wait patiently. We're going to go down and do the next part. Miley?
On the 7.5 you're doing the turtle method, and you forgot to put the feet symbol beside it.
I did. And I just wrote it at the end. Should I have probably written it up there? Yes, I should have. Or I should have written tenths and taken the decimal out. Any of those ways would be right.
Well, you can't like on 7.5 feet. What if you don't put the feet on?
As long as you have it in your sentence, that's good enough for me. I look for that and I count it in the sentence. What about these labels right here, boys and girls?
Underneath?
I have to have them.
Yeah.
I have to have them or it's wrong. Okay?
Put an M.
Right. So get that highlighter again, right? These labels I have to have or it's wrong. And then the only other place I have to put feet is right there. Okay? All right, let's go down to the next one. This one's fun. Okay, it says if the ribbon costs 10 cents per foot, what is the total cost of the ribbon in dollars? Okay, so I need to know how many feet of ribbon. How many feet of ribbon? 555 feet. And then per foot, what am I doing? Multiply, add, subtract, what?
Rounding.
No, per.
Subtract. Multiply.
Multiply. So 55 feet times 10 cents. Now I don't want you to say anything. I want you to see if you can figure out what your answer is. And don't worry about raising your hand. I want you to try and figure out the answer. And then it says, be ready to explain your reasoning, including how you decided where to place the decimal. And I'm going to pause it for a minute, and then we'll go back to talking about it. So right away I look at this and I think decimal hop. Is that what you think?
Yes.
Or I think anything times 10, add a 0 to the end. I know it's something like that, okay? So there's two ways to do it. The first way is just leave it cents. You know how 100 cents equals $1?
Yeah.
So 500 cents would be
$5.
$5, okay? So if I have 555 feet times 10 cents, I'm just going to add a 0 to the end and get 5,550 cents. Okay, now how do I change that to dollars, Miley?
I'm going to say decimal in the middle of 55.
Okay, why did you choose that placement for your decimal?
Because if you put it near the 5 and the 0, that'd be $555. And you also need to use it.
Okay, you need two place values, don't you? Why do you need two place values?
Good.
It's money, isn't it? Yeah, she knew that. She said you need two place values, okay? And she was also reasoning, well, I don't think it's $555. I know it's not $5,000 she's going to spend just to make these hair bows, right? And it's probably not $5.55. That's way too inexpensive. So that's the only logical place to put it. Why did we choose that place? Because when working with money, what place value do you have to use? Hundredths. Very good. So that's what I'm going to write. When working with money, you should use hundredths place. Make sense? Okay, I want to talk about the other idea, okay? Jaden is the one in block 3, and Kristen, this might be what you're getting ready to think of, okay? She said, there's no way you can multiply this. You're going to have to divide it. And the kids are like, no, we have to multiply it. We have to multiply our feet times 10 cents. And she said, yeah, and that's dividing. And here's what she meant. She meant to take a whole number times a decimal. What do? We divide. How many decimal place values do you see? 1. She said there's no way you can multiply it. You're going to have to divide it. So then you get an answer that looks like this. And Miley's going to say, that's not enough. So what do we have to add to the end? Okay. So I like the way she said it. There's no way you can multiply that. You're going to have to divide. Because she already knew it couldn't be 550, couldn't be more than 555. And that's what she was thinking in her mind. Christian, what were you thinking? Oh, what did your sentence say? Very good. I love it. There are always 2 numbers in the decimal place value when working with money. So Jaden's idea of division, when you multiply times a number less than 1, is that really dividing? Yes, it is. And this is less than 1. It's 10 hundredths. Or 1/10. Okay, last problem. We'll see if we have time to do more. So I'm going to go ahead and scroll. You're going to have to look back up in the very first part of your problem. So up in number 6, read that to me. Who wants to read to me today? Lexi. Just read me the first line or the first sentence. Okay, so each bow requires 2.5 yards of ribbon. Don't forget that. Okay? All right, Tobias, you want to read this problem to us? Okay.
Write an expression.
Oh, wait, start right here.
The manufacturer is making 1,000 times as many bows as Pepsi to sell in stores nationwide. Write an expression using exponents to show how many yards of ribbon the manufacturer will need. Do not calculate the ribbon.
Okay, so here's what I want to do. Let's start with Marcy. Let's write down what she used to make her bows. And then we'll take it times what number? Okay, but we don't have to calculate anything. So, that's a long word. I think I just want to call it man.
Yeah, that's what I put.
Okay, so man and Marcy. Now on your test tomorrow, I think this is a different name of a different girl. But that's not going to change it, is it? Okay, so what did Marcy use to make her bows? How much ribbon?
2.5 yards.
2.5 yards. And it says yards here, doesn't it?
Yeah.
Okay. Says yards of ribbon, so you don't have to change it to feet. Okay, so 2.5 yards times how many bows did Marcy make?
1,000.
No, that's manufacturer.
75.
You're close.
74.
74.
Oh, wait.
So that's Marcy. 2.5 yards for 74 bows. If the manufacturer wants to make that many times 1,000, what's the only thing I need to add? I'm going to have 3 numbers in my problem. What do you think? Think about it for a minute. And then you have to put an exponent in. Like 10 to the first, 10 to the second, 10 to the third, 10 to the fourth. It's got to be one of those. Don't say anything, just think about it for a minute. So if the manufacturer is going to do 1,000 times as many as Marcy, Mario, what do you think? Okay, so the manufacturer is doing 1,000 times. He's right on the exponent, it's 10 to the third power. As many as Marcy, what else do I need?
2.5 times 74.
2.5 times 74. Because that part right there is Marcy. The manufacturer is only doing 1,000 times. Now, I suppose you think you know the answer already.
You need to put.
Okay, I don't have to unless I'm going to solve it. And then I don't have to anyway. But Tobias, you're right, because what would we want to leave until the end? 1,000, right? So we can just add zeros or hop the decimal or whatever. Very good. But I don't have to do that unless I'm going to solve it, and it says you do not need to calculate the total. Okay? You guys did a great job. Let's go back and look at number 5. Your brains did great. Now, number 4 is just standard algorithm worth 6 points. Okay? So I'm giving you 6 points to do those two correctly. That means every partial product and add it up. Okay? Let's take a look at number 5.
Okay.
Now, I'm going to read it and then I want you to picture the 5th grade teachers. Okay? We know Mrs. Miller's the skinniest, the prettiest, and the youngest. Well, let's get that out of the way right now.
She's the young.
For a field trip,
How do you not know that?
shh, the school bought 53 sandwiches for $3.75 each. And 47 bags of chips for $1.65 each. How much did the school spend in all? Okay, so let's just say 2 of the teachers went and put 53 sandwiches in their cart. I think we would have had to order those ahead of time from Thrifty, right?
Yeah.
Or Subway or somewhere, okay? And then the other 2 teachers put 47 bags of chips in their cart. And when you get up to the front to pay, how's the cashier going to do that? Are they going to scan one sandwich at a time?
No, they're gonna keep on scanning on one thing because they're all the same thing.
So they're going to scan one sandwich, and then what will they do?
Time.
Times
53.
times 53. And the cash register will do that for them, won't it?
Yep.
And then, what are they going to do with the chips?
They're gonna do the same thing.
Same thing. How much are the chips?
$1.65.
And they're going to scan one bag of chips and then take it times
42.
47. Okay? And then, I want to know what's going to happen next. The cash register is going to do its thing. And there's one more operation that the cash register has to do.
Yes.
It has to add those two together.
Yeah.
Okay? Add tax and all that, but we're not going to worry about that, are we? So it's going to add these 2 products together to get a final total for what the school spent. Okay, I'm going to push pause. We're going to work those out. Then I'll show the answer and we'll be done for the day, okay?
That's a lot of money.
It is. And that's probably cheaper, way cheaper than it would be for 5th grade here.
Yep.
Say it's $5 a sandwich and we have approximately 80 kids per grade level, right? But yes, it would. $400 just for the sandwiches. Mhm. Okay, good job today. You think you can handle those other 2 standard algorithm questions? You might
Yeah.
want to practice. Are there any zeros in those?
No.
Okay, that's lucky. So on your test, you want me to see if there are any zeros? No zeros. All right.